Okay, so to finish up section 4.2, where we talked about the properties of equality, I want to, properties of inequality. I have a couple of additional problems. So these are not in your books. I just want to do a little bit of review before we get into finishing up the homework problems. So let's see. Section 4.2. Bless you. Bless you. I used to have this dainty little sneeze, and now every time I sneeze, it sounds like a nuclear bomb going off. It's awful. Okay. Oh, goodness. The sneezes. All right, these are additional problems, so go ahead and write them down as we go through. So for 1 through 5, we want to solve the inequality and then graph a solution. So the first one is x plus 7 is less than 15. Pretty sure we didn't do these yesterday. Those of you that have your notes can double check, but they kind of look familiar.
Actually, well, no.
Did we do these? Hold on, let me pause this. Okay, so what do we do here to solve for x? Right, so we do inverse operations. And if we do it to one side, we must do it to the other. So we get rid of that positive 7, x plus 7, by subtracting 7 from both sides. And we end up with a solution that x must be less than 8. Yosh. So let's put it on a graph. So when you graph it, throw 8 in the middle, 9, 10, 7, 6. All right, so where does our graph start? At 8. Is it an open or closed circle? Open, because 8 is not included as a true solution. And then we graph our arrow pointing down. Any number less than 8 is a true solution to this problem. Now, you can always check these by, give me a number less than 8. Anybody? 5. So if I have 5 plus 7, I'm plugging 5 into the value of my x up here. So 5 plus 7 is less than 15. 5 plus 7 is 12. Is that less than 15? True. Then we were right. Okay, number 2. Make these just a little bit thicker. All right, so number 2 is x minus 2 is greater than or equal to 4. All right, so I'm going to go around the room. I'm going to start backwards though. So Eden, what about this one? What do we need to do to solve for x? Right, we need to undo the subtraction of 2. So we add 2 to both sides. And we get the solution that x must be greater than or equal to what? What's 4 plus 2? Okay. So, right. So no, because we're adding 2, that x must be greater than or equal to 6. So if we graph that on a number line, put 6 in the middle, 7, 8, 9, 5, 4. So where do we start our graph, Eden? At 6. And is it an open or closed circle? Does it include 6 as a possible solution? Can x equal 6? Yes, because this is greater than or equal to, it does include 6. And then x must be 6 or more. So then you draw your graph with the numbers getting bigger. So it goes to the right on the number line. All right, Abigail, next one for you. Number 3. Maybe. All right, so number 3 states that y plus 1 does not equal -5 or cannot equal -5. So what do we do to solve for y? Exactly. And -5 plus -1? -6. So x cannot equal -6. I feel like you got this one yesterday too. This whole not equal to. So when we put that on a number line, what do we put in the middle? Yeah, negative. And then this becomes -7, -8, -5, -4. Because remember, we always want to make sure that when they're negative, right, the smaller negative number has a higher value. Okay, so we start our graph at 6. Is it open or closed? Right, because it cannot include -6. And then which way does our arrows go? Right, we go in both. Because as long as the number is not -6, it is a true statement. Okay, Andrew, number 4. So number 4 is x minus 3 is greater than -4.
So we add 3 both sides.
Right. So we add 3 to both sides, just so my video can hear, because I don't think it can hear you guys back there. And we find that the solution is x must be greater than -1. So when we put that on a number line,
Start at -1.
yep,
It's an open circle. Then behind it is -2. And then the arrow is pointing to the right.
right. So as long as the value is greater than -1, it is a true statement. All right. Number 5, Gabe. So number 5 states that y minus 9 must be less than or equal to -8. So what do we need to do to isolate our variable? Add what? Right, so we add 9 to both sides and we get the solution. Y is less than or equal to +1. So then we graph it. We have 1, 2, 3, 0, -1. Where does our graph start? At 1. And is it open or closed circle? Right, because it's equal to, so it can equal 1. And then which direction does our graph go? So the numbers get bigger? So y is greater than or equal to 1? Yeah, so the other way, it's less than. So y must be, our solution must be less than or equal to 1. Okay. All right, so let's solve. Now we went through the multiplication property of inequality. So we're going to look at working through these. Solve. So you don't have to graph it. But if I have, to number 6, I have 5x is less than 35. So what do I need to do here to isolate my variable? Oh, no, this is in my additional problem. So this is not in your book. We got to divide both sides by 5. And is 5 positive or negative? It's positive. So we don't have to flip our inequality sign. So x is still less than what? 7. Yeah, that's what you meant. I knew what you meant. Yes, so x must be less than 7 for 5x is less than 35 to be true, which we know that's right because 5 times 7 is 35 and 35 is not less than 35. So it must be less than 7. Okay. Okay, number 7. So back to you, Eden. This one is -2x less than or equal to 12. So what do we need to do to isolate the x? Yes, so we divide both sides by -2. Now, this question is for the room. Do we need to flip our inequality? Do y'all remember this from yesterday? If we multiply or divide by a negative number, we have to flip our inequality sign. So I'll show this to you guys again after we're done with these. So because we are dividing by -2, we must flip our inequality to say x is greater than or equal to, and then Eden, what is 12 divided by -2? Yeah, -6. Now, the reason for that is because when you multiply or divide by a negative number, you are going to be changing the sign of your solution, which means if that was -12 and you divided it by a -2, you would end up with a positive. Because it's +12 divided by a -2, it has now become a negative number. If you are not sure if you should flip or not, then plug your answer in and see if it makes sense. So give me a number that is greater than, we'll do greater than. Give me a number that's greater than -6.
I'm sorry. 1.
1, we'll just throw 1 in there. Sounds good. So -2, that's an easy one to check. So yeah, that's a great choice. And plug it right back into your original inequality. So -2 times 1 is -2. Is -2 less than or equal to 12? Then your inequality is true because you picked a number greater than -6. If you weren't sure, if you didn't flip this, if you left it the same, let's say we left it as x must be less than or equal to -6. So we'll pick -8. If I did -2 times -8, and I'm sticking with my original formula, is less than or equal to 12, what's -2 times -8? It's a +16. +16. Is that less than or equal to 12? No, it's more. That's how you know you need to flip your sign. Just look at it, and if you, like we say, x is less than or equal to -6, and you're like, is that right? Should I switch it? Then find a number that's less than -6, plug it into your original value, and see if it makes a true statement. If it does, you're good. If it doesn't, you probably should have flipped your sign. Or check your math. But usually the math part is the easy part. It's the flipping the sign that people get really, really confused about. Having to reverse your inequality. Okay, let's move on. Number 8, Abigail. So number 8 is 1/8 y is less than 5. Do you know how we would rewrite this? How I would rewrite it? Yeah, it's currently y is being multiplied by 1/8. But you know, this is the same. Let me show y'all something. If I have 1/8 times y, that's the same thing as 1/8 times y over 1. And so, well, it's not an equal sign. I'm going to do this. It's like the same thing. So if you multiply your numerator, 1 times y is y, and 8 times 1 is right. So 1/8 times y is the same thing as y over 8. Wow. Wait. Yes. Yep, that would work too. Or you could recognize the fact that a variable times a fraction is the variable in the numerator and then the fraction denominator in the bottom. So when you see this, y divided by 8 is less than 5, what do you need to do to isolate the variable? Yeah, so then we multiply by 8. These cancel each other out, they become a 1. And so you're left with y must be less than 40. Now, when we did this, did we do this right? Do we keep our inequality the same? What do you need? And this is for the whole class. What do you need to reverse your inequality?
You're multiplying negative numbers or you're dividing negative.
Right. So if that 8 was negative, you would need to recognize that fact and that you needed to flip your inequality sign. Because it's positive, we're good. But if you're not sure, check. Pick any number less than 40. I would pick a number divisible by 8. We can say 32. So if we plugged 32, which is less than 40, we did 1/8 times, I'm gonna just do this so y'all can see what I'm doing here, is less than 5. That's 32 over 8. What's 8? 8 divides into 32 how many times? Anybody? 4 times. So that's the same thing as 4. And is 4 less than 5? They're all good. Yes. So that is correct. Y is less than 40.
Answering before someone else because then that feels. I don't want to interrupt the problem like I normally do.
I don't know. A lot of these are, I know I ask them a little bit strange, and so people don't understand what I'm trying to ask, or you sort of get stuck. Okay. So Andrew, what do I need to do to isolate my variable here? Okay.
If X is less than.
All right. So are we multiplying or dividing by a negative number?
Sorry, X is greater than.
Yeah.
positive 12.
Exactly. So because we are now multiplying by -3, we need to make sure we reverse our inequality sign. And so X must be greater than 12, positive 12. All right, last one, Gabe. -4/5 X times X is greater than or equal to -12. Right, but it's a fraction. So we're multiplying and dividing. So there's 2 ways you could see this. You could either recognize that you need to multiply both sides by the reciprocal of -4/5, or you can rewrite it. So remember when we rewrite a fraction, it's like -4/5 times X over 1. So that becomes -4X divided by 5. So we could do that. But what I'm talking about with reciprocal is the reciprocal. I don't think I spelled it right, but I can't. My brain's done. Reciprocal of, I think so, yes, of -4/5 is -5/4. You just flip it. All right. So you could just multiply both sides by
Would be easier.
well, if you do it this way, you see that you've got a 5 in the numerator and 5 in the denominator, and a 4 in the numerator, or 4 in the denominator and a 4 in the numerator, so they just become 1. And a negative times a negative is a positive. So it becomes 1. You just have to then multiply -12 by -5/4. So what is my solution here? That was kind of a crazy one because we don't use reciprocals. First off, do I have to flip my inequality sign? Why? Because I used a negative. Because I multiplied or divided, that's a -5/4. So because I multiplied by a negative, you have to reverse your inequality sign. All right. And then what's negative 12 times negative 5? So we have 60 over 4 is what negative 12 times negative 5/5 becomes. And then that simplifies to, which simplifies to? Yes, sir. So x must be less than or equal to 15. That was a tough one. That was a juicy. All right, so let's do some more practice. Let's work through the homework assignments, and then whatever we don't get to, we'll finish for homework tonight. So we did through number 10. Okay, good. It was in your book. So some of y'all have through 14.
No, I just did actually.
Okay. You were being extra, that's what you're saying. Let me write down the homework assignment and then we'll see how far we get and y'all can finish it tonight. And I would be extremely efficient with your time management. All right. So page, the homework is page 151, I believe, number 12 through 32 even. All right. So let's see what we can get done. Okay, where did I leave off? Aiden, poor thing, you always get to start something new. I don't think these will be too difficult though, because we did some of them. These are just solving, we don't have to graph. So this is on page 151. We'll start with number 12. And that is what? A plus 5 is less than negative 6. Am I seeing that right? All right, so all they're asking us to do is solve for the inequality. What value must A be to make this a true inequality? So what do we do first to isolate our variable? Yeah, so subtract 5 from both sides. We end up with A is less than negative 11. Now, is this right? Do we have to reverse? Exactly, good catch. So you don't have to reverse it because we're just subtracting. We're not multiplying or dividing by a negative. So as long as you're adding and subtracting, don't worry about it. He's like, oh, she almost got me. All right, so yeah, that's correct. All right, back to Eden, number 14. So number 14 is negative. Lovely, you get a tough one. If I can get my pen to work. Negative y over 4 is greater than 3 is what they have us. So because y over 4 is negative, then just put that negative. You can put it with the numerator or the denominator, but I would just put it with the denominator. Saves you a step later on. So I like to move those when I first look at the problem so I don't confuse myself and forget about it later. So what do we need to do to isolate our y here? Because we're currently dividing y by negative 4. So to undo that, we have to multiply. Right, which is the reciprocal of y over negative 4, because that's technically y times 1 negative 1/4. So we just multiplied it by its reciprocal, which is just negative 4, because it's 4 over 1. We just flipped that. So anyway, I'm babbling. Therefore, these cancel each other out, and we end up with y. First off, do we need to flip or reverse our inequality? Yeah. Because we are multiplying by a negative number. So y is greater than must become y is less than. And then what's 3 times negative 4? Yeah, negative 12. And that's correct. If you're not sure, pick a number that's less than negative 12, plug it into the original equation and see if it works. If it does, you're right. It's a quick fix. All right, Abigail, number 16. Number 16 says -3c is less than or equal to -24. I'm sorry, that says 27, doesn't it? Yeah, -27. All right, so what do we need to do to isolate variable c? We got to divide by -3. So that makes this c. Now, do we flip our inequality sign? Yes, because why? We're dividing by a negative. Perfect. And then -27 divided by -3. First off, is our answer going to be positive or negative? Right, because if we ever divide a negative by a negative, we end up with a positive. And 3 goes into 27 9 times. I have to do yeah. I would see that 3 goes into 30 10 times, and 27 is 3 less than 30, so it must be 9. Yes, so C is greater than or equal to 9, makes this a true statement. Okay, number 18, Gabe. What time is it? 2:17. We might can get through all these, except for we have word problems. I'm sorry. Do you want the next one? You want 18? Okay, sorry, Gabe. I skipped Andrew. I'm sorry. So you get it, Andrew. 2/5 S. You're going to turn it into a decimal, aren't you?
I did not actually.
Praise the Lord,
This
because
might not be right.
you
This might not be right, but it might.
decimals make me twitchy. I much prefer fractions. Okay, at least with this kind of stuff, because you just flip them. Just flip them.
All right, hear me out before I do this.
Okay, I want to listen then. What do you want to do?
Okay. Divide both sides by 2/5. Okay.
Right.
Okay. So you divide and then it's S. Okay, and then you have is less than or equal to -2/3.
Oh, -2/3. All right, let's work this out. All right, so this works. This
Wait,
is
does it actually?
this is why multiplying by the reciprocal works. Let me show you. When we divide fractions, what do we have to do? We don't actually divide fractions. We convert it into a multiplication, right? We remember this? No? You have to, this stays the same. Your sign goes from a division to a multiplication. And then what do you do to your second fraction? You flip it, which by definition is the reciprocal of the first number. Or it's the reciprocal of the one I've got circled here. Sorry, that's what I mean by first number. You convert it from a division to a multiplication, and then you multiply by the reciprocal, which is what this is. 5 halves is the reciprocal of 2/5. When you do that, you reduce. 2 goes into 2, these become 1. 5 goes into 5, these become 1. And that's why 2/5 times 5 halves becomes 1, because it's 1/1. So then we do it to the other side. We end up with -4/15 divided by 2/5, which is what you did. We turn it into a multiplication. It becomes -4/15 times 5 halves. And then you reduce. This becomes a 2. That's a 1. This becomes a 3. This becomes a 1. -2 times 1 is -2. 3 times 1 is 3. And you get the answer -2/3.
Wow.
What did you do?
I divided both sides by 2/5.
With a
So
calculator?
No, with my mind.
How'd you do it?
So 2/5 divided by 2/5 is 0.
1, right? 1.
1s. And then -4. I divided -4 by 2, which is -2.
Okay, and then you divided -15 by 5. Yeah,
Which was -4.
that works too. Yes. As long as you divide the numerator by the other numerator, and then Yeah, the divisor, dividend, never mind, I can't talk, I can't say it out loud.
I just came out with a denominator.
That works.
I just came out with a new math strategy. That's never been done before. Undocumented.
Okay. All right, so number 20, Gabe. Very similar. We have -3/4 R. No, where am I? Number 20. -3/4 T is less than -9/10. So what do I have to do to isolate my variable T? Divide by what?
Using the Andrew strategy. What?
Divide by the -3/4. I don't need one. So -3/4 divided by -3/4 makes that 1 T. Do I need to reverse my inequality sign? Why? Yeah, because it's negative. So T must be greater than -9/10 times 4/3. This becomes 1, this becomes 3, this becomes 2, this becomes 5. And we end up with the answer +6/5.
Cool. Got that one. I'm really proud of myself. That one was a little hard to work out.
Mhm. What you're doing is still the same thing, yeah. Same thing we do with multiplication. Come on. You're dividing. Sort of. But we reduce first if we can.
That's my strategy.
I don't know if that would work in this case.
Uh,
Because 3 goes into 9 3 times, but 4 does not go evenly into 10.
you can do a calculator.
Yep. So no,
Okay.
that does not always work. That's why it's not a thing.
No.
All right.
I didn't.
Well, you would use a different ratio. I mean, sorry, I said that wrong. You would use the fraction 3/4 with different numbers.
So even if you didn't have a calculator, it would work. So if you didn't.
Well, you could use a TI calculator that converts decimals into fractions because you have, I don't know, it would be limited. That would probably work. All right. Let's
So my
do,
strategy will work, by the way. Will it? Yes, no. Simple.
I don't know, I don't have time to do it right now. No, y'all are gonna have to finish them for homework. All right, so go ahead and do 22 through 32. Sure. Yes, please. Let's do it. We got a minute. We can do it. So 22 is 2 times 4 in, what is it? Is less than 6? Is that 2? It's 2 times 4. That's a multiplication.
Wow, Aiden.
So what's 2 times 4? So we have 8 in, and then we divide by 8. He feels like he's quick on his feet. Because he.
You should use the Andrew strategy.
All right.
Andrew strategy
All right,
works
if we
every time.
reduce 6/8 to its lowest form, it's 3/4. So n must be less than 3/4. All right, guys, I need number 24 through 32 even tomorrow.
Andrew